Have you ever looked up at the night sky and wondered if the moon is staying put? It seems like a permanent fixture in our lives, but the truth is much more dynamic. Scientists have discovered that our celestial neighbor is slowly drifting away from us. Every single year, the moon moves about 3.8 centimeters further into space. This distance is roughly the same rate at which human fingernails grow. To understand why this happens, we must look at the powerful force of gravity. The moon's gravity pulls on Earth's oceans, creating what we know as tides. These tides create a slight bulge of water on both sides of our planet. Because Earth rotates faster than the moon orbits, this tidal bulge is pulled ahead. This physical bulge actually exerts a gravitational tug on the moon itself. This extra pull gives the moon a tiny boost of energy in its orbit. As the moon gains energy, it naturally moves into a higher and wider path. Think of it like a spinning skater who moves their arms outward to change speed. This phenomenon is a perfect example of the conservation of angular momentum. While the moon gains energy and moves away, the Earth pays a heavy price. The friction from these moving tides is actually slowing down our planet's rotation. Billions of years ago, a day on Earth lasted only about 5 hours. Thanks to the moon's influence, our days have stretched to 24 hours. Every century, a day on Earth becomes about 2 milliseconds longer. We can measure this exact distance today using specialized laser reflectors. During the Apollo missions, astronauts left mirrors on the lunar surface. Scientists bounce lasers off these mirrors to track the moon's position with precision. This cosmic retreat has been happening since the moon first formed. Most experts believe the moon was created by a massive collision long ago. A Mars-sized object likely crashed into Earth, throwing debris into orbit. When the moon first formed, it was likely 10 times closer than it is now. Imagine looking up and seeing a moon that filled half of the night sky. Over millions of years, the tides have pushed it to its current location. This movement affects more than just the view from your backyard. The moon acts as a stabilizer for Earth's axial tilt over long periods. Without the moon nearby, Earth might wobble wildly like a dying top. This stability is one of the key reasons why life was able to thrive here. If the moon continues to drift, our climate could eventually become unstable. However, you do not need to worry about losing the moon anytime soon. The process is incredibly slow and will take billions of years to finalize. Eventually, the Earth and Moon will reach a state of tidal locking. At that point, Earth will always show the same face to the Moon. A single day on Earth would then last about 47 current days. But long before that happens, the Sun will likely reach the end of its life. The Sun will expand into a red giant and potentially engulf both bodies. It is fascinating to think that our silent guardian is slowly saying goodbye. Each night, the moon is just a tiny bit further away than the night before. This cosmic dance reminds us that nothing in the universe is truly static. Even the most solid objects in the sky are part of a changing system. Space exploration continues to reveal these hidden secrets of our solar system. Understanding the moon's journey helps us predict the future of our own planet. We are living in a unique window of time where the moon looks perfect. Total solar eclipses are only possible because of the moon's current distance. Eventually, the moon will be too far away to fully cover the sun. Enjoy the moonlight tonight, knowing you are witnessing a slow-motion cosmic departure.